Shrieker, and I'm on the programming sub-team, and I'm leading the design team project for programming aspects of the chassis. And right now we're working with the Mecanum chassis. So the chassis is fully built and wired mainly, but code is also for drive is mostly good. We have both field relative drive and robot relative drive with current limits, idle mode, and drive working pretty well with strafe. Some things we can improve strafe, such as there's some turn factor, we're trying to improve that. Right now we're getting a camera on the Mecanum chassis, and the camera basically, it's gonna do look at APO tags and get the position from the APO tags. And it's gonna be used for a pose estimator on the Mecanum chassis. And once we get that working, other things that we're planning to do in the future are aligning, taking the able tag position and moving towards it, not just getting the position, and just putting more stress testing, getting our mounts and loads on there, and this Mecanum chassis will also be used as our main competition bot when we get everything loaded up. So.
I'm Rohan, and I'm a returning member from Mechanical Subteam. I've been working on the Mecanum chassis, and basically chassis is like the basic frame of the robot, and it's where all the components of the robot are mounted to. And we've made a few changes to our chassis this year. So instead of a swerve drive like we made last year, swerve drive is generally a better drivetrain in terms of mobility, but this year we're using Mecanum because the swerve drive was not working for us well last year. Another change we made to the chassis is we made it bigger, because last year it was like 27 inches by 27 inches. This year it is 29 inches by 29, so there's a couple inches difference, because it's a lot more area to mount stuff. Right now, we have finished the chassis mechanically and got most electrical components on, I believe, and we're testing it right now with weight system on and everything, and programming. And that's basically all the knowledge.
In the middle of build season, we had a Narnia cleanup project. So first up, what is Narnia? Narnia is a little closet in the back of the shop where we store all of our extra stuff. That has some materials, that has motors, that has wheels, that has electrical components, all of the things. And it was really, really messy and dirty. So one of our mentors, Mr. Schneider, he took the liberty to clean up and take out all of the mechanical items from Narnia that were in there, and then resort them back into Narnia and clean up like the entire floor and everything. So that was a huge change, and additionally, another change was that now only captains and leadership will be allowed to enter Narnia. That way the cleanliness is maintained from here on out. And additionally, we had some metal shelving in front of Narnia, open to the entire shop. That was really loose, and it was letting metal fall out onto the floor, blocking the pathway. So we made lips to hold in the metal and dividers to section it up into different types of metal that we have to improve the organization.
Talk about why it's important.
And organization in the shop is vital because, I mean, think about it. When you're trying to make anything, what do you first need to do? How am I going to make it, and what am I going to make it out of? You got to find what you're going to make it out of and how you're going to make it. Those two are directly linked to organization of our tools in Narnia and our material.
Hi, my name is Ryan and I'm on the electrical sub-team, and currently we're testing motors and other electrical components for the robot to make sure that all of them work when we put them on the robot and make sure that nothing like breaks, I guess. We also mounted like a bunch of the components onto the chassis so then programming could like practice driving the robot. Yeah.